Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3459. Length of longest V-shaped diagonal segment. You are given a 2D integer matrix grid of size n into m, where each element is either 0, 1 or 2. A V-shaped diagonal segment is defined as the segment starts with 1. The subsequent elements follow this infinite sequence 2 0 2 0, right? So first 1, then 2 0 2 0. All right. Okay. The segment starts along a diagonal direction, top left to bottom left, top left to bottom left, bottom right, bottom right to top left, bottom right to top left. All right. Top right to bottom left, top right to bottom left, like this, or bottom left to top right, bottom left to top right, like this. All right, the continues the sequence in same diagonal direction. All right, and makes at most one clockwise 90-degree turn to another diagonal direction while maintaining the sequence. All right, so 90-degree clockwise direction. So clockwise means if you are going here, then next time from here 90-degree, right? So 90-degree clockwise means then you can move to this direction, right? 90-degree clockwise. Or if you are moving uh, here, let's say like this, then again 90-degree clockwise, 90-degree. Okay, so this case you can say it is nothing but your bottom right to top left, right? And then top left to you are going to the top right, like this. Okay, and here if you start from your bottom left, then from bottom left you are moving to top right direction, and then if you make a turn to 90-degree clockwise, then you are moving to bottom right. Clear? All right, so I have covered this and this direction. Now let's see if you are going in this direction, right? Then if you make a turn to 90-degree clockwise, then you are going to move to this side, right? We are moving clockwise, right? So here you can say you are coming from top right to the bottom left, and then from bottom left you are moving to this top left. All right, clear? So this is also done. Now here if you are moving in this direction, that simply means you are coming from top left, and then here you are moving to bottom right direction, right? Then if you make a turn to 90-degree, then you are going to move to this direction, which is nothing but your bottom left, right? Clear? So here this is what we are doing, right? So we can only move diagonal, right? So this arrow, this is nothing but my top left corner, right? This arrow is nothing but it is pointing to top right corner. This arrow is pointing to nothing but my bottom left corner. This arrow is pointing to nothing but my bottom right corner. Clear? Right? So if I make turn, so see this is 90-degree, so here top left, and then we are moving to top right direction, right? So top left to top right. So here if you say, see here top left then top right. Okay, so this is your case 1, let's say top left to top right. Then here if you see this arrow, so here it is moving to your top right direction. All right, so let me write it here as well, so that you guys don't get confused. Bottom right and bottom left. So here top right, and then we are moving to bottom right. Okay, so top right then bottom right. So this is case 2, right? And then here if you see you are moving to bottom right, and then suddenly you move to bottom left after one turn, right? 90-degree. So bottom right then bottom left. So here here if you see this bottom right and then bottom left, right? So here see bottom right and then bottom left. So this is nothing but the case 3, let's say, right? And here if you see if you are moving to bottom left, then suddenly you move to top left after making clockwise. So bottom left and then this top left, bottom left then top left. So here see bottom left then top left. So this is nothing but case 4. This is what I explained. All right, so I hope that you guys are clear. All right, and clockwise direction. All right, clockwise means this direction, like this direction, this direction. All right, clear. We have to return the length of the longest V-shaped diagonal segment. If no valid segment exists, then we have to return 0. All right. So here, first, let's discuss about these directions, right? So here, if you are here, let's say if you are at this particular position, right? If you are at this particular position, let's say. So here, let me just write 0 row, first row, second row, third row, fourth row, and here 0th column, first column, second column, third column, fourth column, right? So if you are here, and if you want to move to this side, all right, if you want to move to this side, so here if you see, notice one thing, your I is decremented, right? Here, let's say this is nothing but I comma j, right? Then if you are moving to this point, right, so here your I is decremented, right, and your j is also decremented by 1. So I can write it minus 1, right? Your I is also decremented by 1, right? I coordinate decremented by 1, and your j coordinate is also decremented by 1, right? Here same thing, if you, from this point, if you're moving to this point, your I is decremented, right? So I was 2, you are at this 2, but now you're moving to 1, so I is decremented, so minus 1. But j was 2 here, now it is 3, so j is incremented by 1, right? Same way here, if you are here at this particular position and you are moving to this direction, right, to the bottom right diagonally, so here your I is 2, so next time here I is 3, here j is 2, so next time j is 3, so both are incremented, so here I can say 1 1, right? And same way if you are moving to this direction, right, so here your I is incremented but your j value is decremented, right? I can write it like this. So here this 1 1 is nothing but your bottom right, right, this direction. Okay, if I want to move to this direction, so in this I and j I have to add this bottom right coordinate, right? So what I'm saying here, let's say I am here at 2 comma 2, 2 comma 2, right? Now if I ask you that I want to move to bottom right, so in that case what you are going to do, you are going to add this one to x side, so you are going to get here 3, and this one to y coordinate, so here you are going to get 3 3, so that is right, you are moving to bottom right if you add this one 1. Same way, instead of this, if I ask you I want to move to the bottom left, like in this diagonal, to this next position, right? So in that case what you need to do, you have to add 1 here, so you are going to get 3 as the row, that is right, and here 2, so here minus 1, so you have to do minus 1, 2 minus 1 is nothing but 1, so this is right, this is nothing but 3 comma 1, right? So these are the coordinates that we need to know, right? So here in your code, what you need to do, let's see, this is your code. So here you are going to create this directions, 4 diagonal directions. So here let's say 4 diagonal directions, and these directions are, let's say, your bottom right, and then I will write bottom left, then I will write top left, and then I will write top right. So here I will follow this order, let's say bottom right, bottom right, I'm moving to bottom right, I am moving to bottom left. If I want to move bottom left, then what I need to do, if I want to move to top left, then what I need to do, top left, and if I want to move to top right, then what I need to do, right? So here I will create this direction, so private static, and here final int directions, and here inside this I will write all these directions. So what are these directions? So one is 1 comma 1, 1 comma 1. All right, so 1 comma 1 is for bottom right, so I will add this value to my current direction, so I will move to bottom right, so I can say this is nothing but bottom right. Then next time here I will say after the bottom right, so bottom left is nothing but 1 comma minus 1, so I will write 1 comma minus 1, right? So this is a base of this problem, 1 comma minus 1, so this is nothing but bottom left. And then after that, here this side we have top left, which is nothing but minus 1 minus 1 we need to do, so here I will write minus 1 comma minus 1 for my top, and here left. And next time, okay, here what we have top right. For top right, what I need to do, minus 1 comma 1, right? So here I will simply write minus 1 comma 1, so this is for my top right. So this is done, that's it. So these are my directions. All right, now here if you notice one more thing, if I'm here, then next time I am moving to top right. Okay, if I'm here, next time I'm moving to this arrow. If I am here, next time I'm moving to this arrow. See this. If I am here, next time I'm moving to this arrow, right? If I am here, next time I'm moving to this arrow, right? So here, see this and this arrow, this and then this arrow, this and then this arrow, this and then this arrow, right? Clockwise 90 degree. So if I want to change the direction, so I can say from this I'm moving to this bottom left, right? Bottom right, bottom right. Then after that I'm moving bottom left. From bottom left I'm moving to top left. See, bottom left I'm moving to top left. Then from top left I'm moving to top right. So I have written everything alternative, right? Top left and then top right. Then here when I'm moving to top right, then again after this I'm moving to bottom right. So this is one cycle, right? Top left, top right, and then bottom right, top right, and then bottom right. So this is one cycle. So my cycle is like this: 0 to 1, 1 to 2, 2 to 3, and 3 to 0 again, right? So the in this directions 2D array, this is nothing but your x 0, this is your 1, this is your 2, this is your 3, right? Your directions is like this, right? 1 comma 1, 1 comma minus 1, then minus 1 comma 1, minus 1 comma minus 1, then here minus 1 comma 1. These are your directions, right? Okay, so here 1 comma 1, then 1 comma minus 1, right? Like this. These are your directions that I've written. So this is your nothing but 0, this is nothing but 1, this is nothing but 2 and 3. So here if you see, from 0 to 1 I'm moving. If I want to change the direction clockwise, from 1 to 2 I'm moving, from 2 to 3 I'm moving, and then again from 3 to 0 I have to move, right? Like this. So if I'm moving to this minus 1 comma 1, that simply means you're to your top right, right? Minus 1 comma 1. The next time I have to move the bottom right. So for bottom right I need to change direction like this, 1 comma 1, right? Top right to bottom right. So here when I want to change the direction, so what I will do, so whatever my contraction, let's suppose this is my contraction which is at 0. So in this which is at 0 coordinate, right? 0 index, let's say 0 row. So I will just add 1 to it, right? So that I will get next one. So here 0 plus 1, so that means I'm moving to the next direction. If I'm at 0, then next time 0 plus 1, 1, right? If I'm at 1, then next time I'm moving to 1, so that simply means 2 direction, right? So 1 to 2. Then if I'm at 2, then in this if I add 1, I'm moving to third, this minus 1 minus 1 comma 1, right? This direction. Same way if I'm at 3, now there is one issue. If I add 1 I will get 4, but I don't have 4. I have then start from 0. So what I'm going to do here, I can also write it like this now: 1 modulus with 4, right? I can do like this: 1 modulus with 4. So 1 modulus with 4 is nothing but 1 remainder. 2 modulus with 4 is nothing but 2 remainder. 3 modulus with 4 is nothing but 3 as the remainder. Same way 4 modulus with 4 is nothing but 0. So see, I am moving back to 0. That's it. So this is my next direction. If I'm 0, next time I'm using 1. If I'm 1, I'm using 2. If I'm at 2, I will use 3. And if I'm 3, I will use 0. And I'm going to use this when I want to change the direction. And I can change the direction at most once only. This is also given in problem statement, right? Here, make at most 1 clockwise 90 degree turn. At most 1 only turn to another diagonal direction, right? So I hope that you guys are clear with the directions. So now let's see this example number 1. So this is your grid, right? So here you see all the values. So what is the first thing that we are going to do now? We are going to search for 1, right? So we have to start from 1 only, right? And once we find 1, then next time we have to search for 2, 0, 2, 0, like this, right? So here let's say I find my 1 here for very first time, right? So now from here I have total how many possibilities? I can move to this direction, I can move to this direction, I can move to this direction, I can move to this direction. These are the four possibilities I have, right? So how I'm passing the directions? I'm passing the directions like this. So this, right? Okay, so let's say I'm currently here, right? Which is nothing but your this cell value is nothing but 0 and 0, 1, 2, 3, and 4 here. 0, 1, 2, 3, and 4. So you are right now at 0, 2, right? So now let's say you can iterate from in all the directions, right? In all 4 directions. So let's say first I want to move here. So I will just run one loop. So first I will try to check this direction, bottom right. So bottom right. So for bottom right, what I need to do, I have to add 1, 1. So here this is going to become 1 and this is going to become 3. So I will go to this 1, 3 next. So now from this, in how many directions I can move? Tell me, think about that. Can I move to all the 4 directions or not? No, I can't move to all 4 directions, right? My target is 2, right? I am starting from 1 and then I'm searching for 2. 2 is here. That's it. After 2, I am finding what? 0 only, right? After 2. After 2, I'm finding 0. because I have to follow this pattern, right? So now for 0, but I can only move to two directions. I can't search for all four directions, because here it is saying that if I move into bottom right, if I move to bottom right, then if I make a turn, I can go to bottom right, good. But if I make a turn, then I can only move to my bottom left, right? So from here I have only two possibilities. I can move to this direction or I can move to this direction. Definitely I'm not going to move here, because here we have one, but we are searching for 0. So that next time I will move here, right? Clear? Now from 0 also I have two possibilities. I can move to this, I can move to this, right? So here this is out of bound, so I am going to move to this direction, and also after 0 I have 2, right? So I can move here. Now if I move here, then I can't make any turn, so I can only look in this direction only. So after that we have 0, so I will reach here. So in total 1 2 0 2 0, so in total 5 blue color ones, right? So output is 5. All right, same way in this case also you are starting from 1, so you have all the possibility. You can move here, you can move here, you can move here, you can move here. But after 1, what you are searching for 2, right? So let's say you move here, right? This is the longest path, so that's why I'm showing. So after this 2, you have two possibilities. You can move to this direction, okay, or you can move to this direction. So if you choose this direction, so 1 2 0, and after 0 what you want to find, let's say you choose this path, okay, you reach 0. Then after 0 you have two possibilities. You can move to this or this. So that's it. Now there is nothing after that, right? Because if you are moving to this direction, then only you can move to this direction, if only by only making one turn, right? You can check any other directions, right? So only 3, but 3 is not the output, because this is the longest path, 1 2, and then this 0, and then this 2. Okay, so here we are turning 4. Same way for this one, this is your output 5. And for this one, if only single element is there, so we are starting from here. After there is nothing, so just return this length. The longest v-shaped diagonal segment has a length of 1 and follows these coordinates, right? And these are the constraints. N is nothing but grid dot length, M is nothing but grid I dot length, N and M value ranging from 1 to 500, and grid ij value is either 0 1 or 2. So let's take the example number 1. So now you are clear, right? We have to iterate over all the cells, and as soon as I find first one, right? So after 1, what is my target? My target after 1 is 2, right? And from this one I can move, or I have to check over the directions, right? This. So first let's say I pick this bottom right direction, so I move here. So if I move to this cell, right, then I can only move to this direction or this direction, right? Only these two possibilities, right? But here one more thing, after 2 my target is 0. So what I'm going to do here, first my target 2, then next time what I'm going to do, I'm going to write here the next time my target as 2 minus the previous value here, 2 minus previous target. So this is my current target. I was searching 2 here. The next time my target is going to be 2 minus t, that is 0, right? And next time my target is again, I will write 2 minus t. So here t last time from was 0, so next time I was searching for 2. So again next time when I want to search for t, so 2 minus previous t value is 2, so I will get 0. So see, 0 2 0 2 0, so we are getting this sequence, right? So I can use this. And since we have to check all the 4 directions, so I will simply run one recursion, right? I don't want to solve at each and every step. I will take the help of recursion. Solve it for me. I will ask recursion to solve it for me. Okay, so this is what I'm planning to do, right? So this is the one thing that I need to take care, and also I need to take care one more thing, that I can take at most one turn, right? So I can say that I will create one variable. Let's say I can create one variable can turn. So initially I will set this value to true. You can make one turn, right? But as soon as I make one turn clockwise 90 degree, I will set this value to false, so that later on I can't make any turn. So this is one more thing I can do here to solve this problem. All right, and also I need to make sure I don't want to go out of bound right here. So I will also check few conditions, like my next coordinate of x, my next coordinate of y, it should be greater than 0, and it should be less it should not be less than 0, right? I can say, and it should not be more than number of rows or more than number of columns, right? So that's mean out of bound, right? And if I move into next section, I have to make sure that I'm getting the target that I want there. So if it is not equal to target also, then also I don't want to move, so I can simply return 0 from there, right? This is one thing. And we have to keep going straight in the same direction, right? If I start from here from 1, then next time I can move to the state in one same direction, or I can take one clockwise turn only if we still can, right? So I will do that. So this is one thing, and I have to check all the possibilities, all the 4 directions that I'm moving. And yeah, that's it. Let's write the code. All right, and I will explain every line of code what I'm going to do, right? So here do one thing. create one grid also here outside this method, right? Because I want to use the same grid somewhere outside. Okay, so here I will write private int grid, same grid. Okay, whatever grid here, I'm just using it here. I will initialize it inside the method only, but I am going to use create one some other method, and that method also I'm going to use this, right? So here this is one thing that I'm going to do, and here I will write private int rows and calls. So I'm just going to count the number of rows and number of columns I have, right? So here in this method, all right, so what I'm going to do, I'm going to assign the values, right? So this dot grid is equal to grid, right? And here this dot rows, right? So I'm assigning what I'm assigning grid dot length value to my rows, right? And same way I'm assigning my grid 0 dot length, that is nothing but a number of columns, right? Number of columns to my calls. Okay, so this dot calls. So this is done. This is basic thing, right? Now after that, once this is done, then after that what you need to do, so here we can move to any four direction, right? Initially, so first here I'm going to create one variable longest, right? And I'm going to set it to 0, right? We have to find the longest length. So here after that, for int I is equal to 0, I is less than rows, and here I plus plus, and here inside this for int j is equal to 0, j is less than calls, and here j plus plus, right? And here only if current value is 1, right? So here I can say if grid I comma j value, if it is equal to 1, then in that case only you have the choice to move in the four directions, right? So int, and what are the four directions? These are the four, right? This, right? So int dir is equal to 0, dir is less than 4, and here dir plus plus, right? Four directions. So we have to start walking diagonally, so I can say here start walking diagonally, and here sequence always starts from 1, right? Sequence starts from 1. So next expected value is 2, right? This is what I'm searching for. So here I'm going to update my longest. In longest I have to find the max value, right? So here math.max, in all the four directions I have to check, and in which direction I'm going to get the max. So that value I need to store here, longest. And here I will take the help of my recursion method, okay, DFS, let's say. So in this, where I'm at I comma j value, right? I'm at I and j. Then after this, if I want to move to the next coordinate, so I can simply use what I can simply use the direction. Okay, so here I will just pass dir, right? Here I will simply write dir. Okay, and this is done. And here next time I can make turn, right? I can make turn. So here I'm just going to set true, and my target is 2, right? So in this DFS also I'm going to add 1 because I'm starting from this first cell, right? So longest initially is 0, and then 1 1 1 why? Because we have found 1 1, right? Here grid IOJ value. Then next time after this one, what is the value that I'm going to get in that direction? That I will solve using this recursion method DFS. In this I'm passing my current coordinates, the direction, all right? So direction 0 means I will use this bottom right first. Then direction is equal to 1 means this, direction is equal to 2 means this one, direction is equal to 3 means this one, right? And true means that I can make one turn, I have that option right now. And 2 is the next target. After 1 my next target is going to be 2, next expected value is 2, so that is by 2, and plus 1 because we have found this, and then after that I'm moving, right? So this I'm going to do here, and from here I will just return the longest. So this is going to be my answer, right? Now this is done. All right, so here if you see in this DFS method, I have passed I j value, which is coming from here. I passed my dir, which is coming from here, right? This true to okay. But now next time when I'm going to write one method, in that method I'm going to use the grid, right? I'm going to use the this number of rows and number of columns also, right? So if I don't write these things here, then and just simply just simply write the things here, right? Course is equal to grid 0.length, rows is equal to grid dot length. Then in that case, in the DFS method only, I have to pass the grid, the rows, and course, everything, right? So instead of passing so many things in my DFS method, like grid, rows, and course, which we are going to use in the next method, I simply wrote these things here, right? And I just pass the value of grid 0.length to the course, grid dot length to the rows, which is coming from here, and the grid to this grid. That's it. Okay. So that is why I'm writing it like this. But if you don't want to write it like this, like here, you can remove it. Simply here you have to just pass rows is equal to grid dot length, course is equal to grid 0.length, and here in the DFS you have to pass grid, rows, course also along with these values. All right. Okay. So now not here, here. Let's write the code for this. All right. So here you can say private int DFS. Here you have to pass current coordinates int x, int y, and int dir, and here boolean can turn, and here int target. Okay, so these are the things that we are passing in DFS. So here my new x coordinate and new y coordinate I have to find, right? And that is very simple. How? Whatever my x, in this x, what I have to pass? I have to pass what? I have to pass this from this, okay, this directions, right? I have to add this value, right? So in the x I need to add this value, in the y I need to add this value, right? So here in the x I can say this, and here dir, right? Dir 0 means that this one I'm calling, right? In this 0 I want this value, first value, right? This is nothing but 0 coordinate, right? So here 0. So this is what I need to do here. And for y plus dirs, okay, and here dir, and here 1. Clear? Until now I hope everything is clear, right? Done. Now here if we go out of bound, right? If we go out of bound, so here let me write the comment also for simplicity. If out of bounds or value doesn't match target, that's also we need to check, right? Value doesn't match target, then we have to stop here only, right? So here what you need to do, just one base condition, if new x value, okay, new x coordinate value is less than 0, right? Or new y value is also less than 0, or you can say your nx value is greater than equal to the total number of rows. So now this rows is nothing but the grid dot length, right? So that's why I have assigned it here, right? If I don't assign it here, so I have to pass it here, right? Otherwise my code will give error, right? So here see I'm using rows also, which is nothing but the number of rows. Here same way, new y value is greater than equal to course, right? Or here grid nx and y value is not equal to the target. All right, in that case you have to just simply return 0. So I hope that everything is clear until now, right? Now after this we have two cases, right? One is case 1. Once we start from 1, right, then after that if I follow this direction, then I have only two possibilities. If I can move straight, right, keep going straight in the same direction, that is nothing but case 1. And case 2 is nothing but take one clockwise turn, only if we still can, right? And we can right now, can turn, so this is true value, right? So we have two cases, case 1 and case 2. All right, so in case 1, max steps we have to calculate, right? Max steps. So here what I'm going to do, I'm going to call this DFS method only again. So we are moving in the same direction, right? So I'm going to call this DFS for next, right? If I'm moving in the same direction, then definitely from here I move to here, right? That's the meaning of this one, right? So what I need to do here, if I'm moving the same direction, so I'm going to call here case 1, lets me write here, keep going straight in the same direction, all right? So here DFS, and here next time my new x coordinate is going to be nx, my new y coordinate is going to be new y, and here I'm just going to pass dir, right? All right, and here I will pass can turn. Okay, so we can still turn, right? And next time my target is going to be 2 minus target. All right, this is done. Clear? This is my case 1 for the max steps, right? Now if I make the turn, right? So here I will write take 1 clockwise turn only if we still can, right? So here what I will do, I'll write it like this: if can turn value is true, right? In that case only I can move to new direction. Okay, so what is going to be my new direction? My new direction is going to be dir plus 1. Okay, in this I have to do the plus 1, so I will get the next, like if 0 I will get 1, if I have 1 I will get 2, if I have 2 I will get 3, if I have 3 I'll get 4, but I will do also modulus with 4 every time, right? So I was doing modulus with 4 here every time, right? So I'm getting 1 2 3 0, right? So this is what I need to do here. Okay, so here dir plus 1 and modulus with 4. So here you can say clockwise turn, right? And then in that case what is your going to be max steps? Max step is going to be nothing but math dot max of max steps, whatever the max steps value. Okay, and here dfs you are going to call again, again you are going to pass new x new y, again you are going to pass dir, right? Here you are going to pass new dir, right? Since you are moving to new direction, right? So here new dir. All right, and here now you are going to set it to false because you can't move, you can't take any turn further, right? So false, and next time your target is going to be 2 minus target. So these are the two possibilities, right? From one cell I can keep moving in straight direction or can make a 90-degree turn clockwise, right? So here that is why 2 minus target, 2 minus target, right? So now this is going to solve everything for me, right? And here once this is done, then from here what I will write, I will simply write return the max steps, whatever the max steps that I'm going to get from these two steps. In this I have to add 1, right? Because from 1 I'm moving to maybe straight or maybe clockwise 90, so plus 1 we have to do every time, right? So from this I can move to this, I can move to this, right? 90-degree. I have checked these two things from this point, but from this point I'm moving further, right? So I have to add this in my output, so that's why 1 plus I'm doing here, right? So now if I run it, let's see if the input will try to fix that. So yes, two errors, line number 24 and line number 49. All right, so line number 49 and line number 24 here. All right, so now let's run it. So there are few more issues. So here, okay, so I think this C should be small, and here why I'm using K, that we need to fix. So here, where is this? Here Canton, right? So this is wrong. This C should be small, and here one loop. Okay, here I've used J instead of K. Now let's run it again and let's see. Line number 49 also a new dir. Okay, so this is wrong. So okay, new na, here I am writing and I don't know why. All right, so now let's run it again. So see, all 4 test cases has been accepted, but will we able to pass our solution or not? Let's see that. Will we able to pass all the test cases or not, or will we get time limit exceed error? Let's see. So nice, we are able to pass all the test cases, right? So there is no need of memoization also, right? We are able to pass all the test cases, right? And how many code lines we have written here? Just few lines, right? But if you want to use memoization, then I can also do that if you want. Let's do that, right? Only 46, but code will be a little bit lengthy, but we are able to pass all the test cases, you see, right? Okay, so here, all right, so there may be some cases, right, that from this point I am moving in this direction only, right? And I have calculated this result in the past, right? And I from this point I can't make any other turn. I calculated this value, right? Now same way, let's say what happens. All right, so let's say I'm moving to this, right, this direction. Okay, so I have already calculated this value. I have already calculated this value in this direction. So here if you see there's any arrow in this direction, okay, So this, right, if this arrow, right? Okay, so you can see this case, this is good, right? So let's say I already know the value of this output, right? And I can't make any turn, and I already know this value, right? Now in the future, maybe you find one here, and then you move here. Then here you have two options, whether to go straight or whether to make a 90-degree turn, right? So you can make one turn. So but after this you can't make any turn, right, in this screen, right? But you already know this blue value, output of this blue value. So you are going to store this blue value result somewhere, right? Okay, so that you no need to calculate this part again and again. This you can do, right? So that's why we are going to use memoization here. So in memoization, if you notice, how many things are changing? In memoization, if you notice, only few things are changing. That is your x coordinate, the new x coordinate, the new y coordinate, direction, right? And turn used, right? We have to make sure that whether we can still make any turn, right? Because this in this arrow we can't make any turn, and I know the value. And from this also, this green arrow also, if we make a turn, then also we can't move, right? So I know this value. So only four things are changing, right? So I can use memoization using that. So here what you need to do, not required, but if you want to memorize your code, so then it's also fine. So here what you need to do, here I will write memoization. Here dp x y dir or turn used. Okay, only these values may change, right? Every time turns used, you can say, right? Only these values. So for these four values you can create the memoization array. So here you can do one thing, create one memo array like this. Let's say memo instead of dp, let's say memo. Okay, so this is done. And here you can do one thing. Here you initialize. This is how we do the memoization, right? Initialize memo with -1 means not computed yet, right? Means not computed yet, right? And here just we have to do one thing. This dot memo is equal to new int, and here four things we have to pass. That is nothing but the rows length, course length, right? And here four other total directions, right? Four. And here can turn or cannot make any turn, right? So you have two values, right? If you can make a turn or if you cannot make any turn, right? So let's store here two only, right? Two, right? That's what I'm doing here. And after that, here do one thing. Just this is your method, just copy this. I will initialize everything with the -1, right? So I'm just going to copy this here, and here I'm just going to paste it. I don't need this, right? All right, only these are enough. And here I will just simply say, okay, so here I will simply say arrays dot fill what memo, here I, j, and dir with all with -1 initially, right? So we initialize the memo with -1 means not completed yet. All right, this is also done here, and that's it. Okay, and now here this is your code. So here we will write one base condition. Okay, base condition is going to be like if memo nx ny, okay, only these coordinates we need to check now, nx ny dir, and here turn used, right? Turn used. So here if this value is not equal to -1, then in that case you can simply, that simply means that we have already know the value of this, right? If this value is not equal to -1, so I'm just going to simply done it. And this memo nx ny and this value I will store it here, right? Whenever I'm going to calculate this, so I will store this value here, right, to update. Okay, and here this turn used, this has two values, right? 0 or 1. So I'm using array, right? 0 or 1, right? So let's say here int turn used, okay, if it is equal to can turn, so then just take it 1, right? And 0 means false. So
0 means you can't make any change in direction in the future. 1 means that you still can, right? So turn used, we have two values only, 0 and 1. 0 means you are not able to make any changes, and 1 means you can make changes. Okay, so now let's run it and let's see if we are able to pass all the test cases or not. Yes, we are able to pass all the test cases. Okay, so last time we are here, right? It is nothing but 1063 milliseconds, right? So now let's submit the solution and let's see. So see, this time we are here, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.